Okay, let's quickly take a look at task 2.3 and implement task 2.3. Okay, this is a repeat loop, right? And this is what we are supposed to do. We are supposed to output the character corresponding, we've already covered this in task 2.2. So this is going to output the character corresponding to the ASCII value held in location X, right? And this is our location X, and it is holding this value 90, and 90 is the ASCII code for capital Z. Okay, so this instruction basically is going to output capital Z on the screen, right? And then we are going to decrement the value of X, and then we're going to do this comparison, right? So this is very simple. Let's get started, right? Okay, to output the character corresponding to X, we first need to load X into the accumulator, right? So we first need to load X into the accumulator. So we're going to do what? We're going to do LDDX, right? And that would load what? That would load this value into the accumulator. So our accumulator is going to become 90. Then we are going to, because we have to output the character corresponding to the value held in X, right? And that value has now been loaded into the accumulator. We can use the out instruction. What the out instruction is going to do is, it's going to take this ASCII code, it is going to convert this into a character, which in this case is going to be capital Z, because 90 is the ASCII code for this character, capital Z, and it's going to show this in the output window. So this Z is going to be displayed in the output window. Okay, now once this has been done, this is what we need to do. We need to decrement the value of X by 1. We want to decrement the value of X by 1. Now what we should know is that X is already loaded in the accumulator, right? This is what we did. So X was loaded into the accumulator, then we output the value, then we output the character corresponding to X. So now what we need to do is, we can simply decrement X. So we can say decrement X. So that's the instruction, right? And you can see that this decrement instruction is, you can, as the operand in the decrement instruction, you can pass the register, right? And the register whose value that we want to decrement this time, the register whose value we want to decrement is this register, right? The accumulator. So I should not be saying decrement X, rather I should be giving the name of the register, right? So this is what we are going to do. We are going to write accumulator here, right? Because the value of X is loaded into the accumulator, so we are going to decrement that by 1, and this value instead of 90 is going to become what? Instead of 90, this value is going to become 89, right? Because we are decrementing this by 1, right? So now this value is going to become 89. Once this value has been decremented, we want to store this value back into X. So we are going to say store X. What is that going to do? This is going to take this value from the accumulator, and it's going to store this value at this location, which is pointed to by this label, right? So instead of 90 here, we are going to overwrite this, right? And instead of 90, the new value that is going to be stored here is going to be 89. So once we've stored this value, we need to check what? We've come to this statement, right? Until X equals A. Now X equals A means what? Compare the value of X to A. For the comparison, for comparison, we have this instruction, right? Comparison with the value that is held at this address, right? And the address in this case, we are going to say compare with A. Let me write that again. Compare CMP, and the address is going to be A. So whatever value is held at address A, compare that with the contents of the accumulator. And we know that the contents of the accumulator are what? The contents of the accumulator are X, right? Because we just decremented the accumulator in the previous step, and then we stored this value at the memory location pointed to by X. So this is the most recent value of X, right? And we want to compare this value 89, which is held in the accumulator, with whatever value is right now in location, in what location? in at location A, right, and at location A we have this value stored, right. So 89 technically in our example is going to be compared to 65, and the instruction for that is what? We can say CMP to compare, and then we can give the location where that value is lying. So that value is lying at location A. So compare the value at location A with the value in the accumulator, right, and we know that in the accumulator the value right now is X, right. So these two are going to be compared. If the result, if X is equal to A, then we are going to jump to end, but if X is not equal to A, we are going to jump to the start, and the start is indicated by what label? Loop, right. This is the label, right. We've used the label loop. We could have used the label repeat here also. We could have used repeat instead of loop, right. We could have used repeat here instead of loop. So after comparison, if the result does not match, jump. In case the result is not equal, jump back to loop, right. So the control is going to be transferred once again back to this position, and then once again this instruction will be executed, this will be executed, this will be executed, and this is going to keep on happening until the value of X becomes equals to A, until the value of X becomes equals to A. And notice that the value of A is what? The value of A is 65, and each time this loop is going to run, the value of X is going to be decremented, right. X is equal to X minus 1. That's what we are doing inside the loop. X is equal to X minus 1. So this value 89 is then going to become 88, which is then going to become 87, which is then going to become 86, until we keep decrementing, and there will come a stage when X will equal 65, and then these two values, value of A is going to match the value of X. Until that point X will keep decrementing, and until that point we are going to output the character corresponding to the value of X, right. And guess what? The first character that was printed was Z, capital Z, when X was equal to 90, right. And then when X was equal to 89, then this capital Y was printed, right. And when X becomes equal to 88, WX, so X is going to be printed. When X equals 87, capital W is going to be printed. So what this piece of code is doing is, it is going to print the capital or the uppercase ABC in the reverse order. Z, how do you say? WXYZ. So Z, Y, X, W, right, in the reverse order all the way till A. So that is what this code is doing, right. So if the comparison is not equal, then we are going to jump back to loop. If the comparison is equal, obviously we are not going to jump back to loop. Then the next instruction is going to be executed. We are not going to be taking this jump, so the next instruction will be executed, which is going to end our program.